Alright, so this is my idea for a suspension system. And this suspension system is mainly meant for high-end $70,000 plus vehicles, sports cars more specifically, and luxury sedans. It would work in very well too, but mainly stuff that has enough horsepower to the point where you need to start worrying about suspension and how the vehicle is set up geometry wise, with the wheels in reference to parallel to the vehicle's body and the rear wheels. Now, this vehicle is going to use a very traditional style of suspension, but with some additions and modifications. So, this vehicle will use a traditional McPherson strut design, right? And the difference with this design is that most of the weight is, weirdly enough, it is going to be supported by hydraulic fluid instead of the spring system like you'd expect to see. Now, this is all for a good reason. The entire system is hydraulically operated to give you flexibility in the geometry of the suspension at each wheel. Each wheel will receive a slave unit, a hydraulic pump and reservoir, and linear actuators on everything we can put them on. Now, with the linear actuators, it'll allow movement in a linear axis via hydraulic pressure, linear being straight. So, when we move it linearly, we're going to see this expand and this will contract. So, that would lead to a toe in. Now, we can have this all move independently, so we can add camber, toe, all of that on the fly while driving. Now, this will allow a lot of good setup. Now, you can set the car to different modes via the master unit. So the master unit controls all these slave units. So when the master unit sends a command to the slave units, the slave units tell the master unit what the current output is of the linear actuators, these hydraulic lockout sensors, all that. And then the master unit will then tell the slave units what to do. And the slave units are at each wheel to allow fast processing. The slave units won't need as high quality, computers. They'll really need some stuff that can read sensors, because there's going to be angle sensors on the shock right here, so it can tell what the current position is. So if it's rolling a lot, this will be compressed more near the top. And this hydraulic lockout sensor here is on the caliper. The caliper is allowed to move like this, a small amount, to hit a button here that'll tell the system management slave unit that it is braking. Now, this will then feed back to the master unit with what it needs. So under braking, it would send more pressure to the front to try to prevent nosedive, while under acceleration, it would send more pressure to the rear to prevent body roll. And along with this, while you're turning and you get the body roll of steering, it'll send more pressure to the left or to the right. Now, the master unit will come with multiple modes that you can send to it. This being, you can put it in a sport mode, a comfort mode, a hybrid mode. All these modes will allow will set basically an equation of if this, then that for each set of values, and it'll more or less allow the vehicle to handle in a distinct way with each setting. So if you set it to comfort mode, you'll drop hydraulic pressure, so the pump will pull back some hydraulic fluid to ease off pressure on the system. So that way, when you go over a bump, it feels way softer. In the hybrid mode, you'll get a bit more pressure, and it'll allow lockouts. So it will allow pressure to be pushed to these shocks under braking, under turning. Not a lot, but a good amount. In sport mode, it'll basically do everything it can to prevent the vehicle from moving a millimeter. It will send as much hydraulic pressure as needed to prevent body roll, nosedive, all of that. Now, on top of this, this system will since it can adapt while the vehicle is moving, you can set it up for track racing, where as you're going in higher speeds, the toe will go in, and as you start to turn, the toe will push out. So that way you can have handling of the vehicle that's more dynamic as your speed fluctuates. Now, the cost of this is going to be very high, as there is a lot of research and development involved in making these control arms stiff enough to handle the weight of the vehicle while also having these linear actuators put in. Now, the cost isn't determined, as I do not believe that there exists linear actuators exactly powerful enough yet to do this, but always remember, anything is possible with enough R&D. So this would probably be very expensive to research, but it would be great payout. A lot of luxury car makers would love to have this. BMW, Mercedes, who else? Yeah, BMW, Mercedes would love to put stuff like this in their cars, because they sell cars that are both meant to be sporty, right? You can think of the M series from BMW and the AMGs from Mercedes, and you can then think about the interior. How are they on the inside? They're comfortable. Now, they would like to have this because this allows the utmost comfort, and then when the driver demands it, the most performance possible, the most handling. Now, this suspension is a very complex system. There's a lot of failure points embedded within it. It's going to be a difficult to service part. So car manufacturers like Toyota would not want this in their lower end vehicles because of cost and serviceability. So this suspension would serve to a very niche top tier market and would not fit in near the bottom of the totem pole. The biggest overall pro is, again, the adaptability. Like, I'm telling you, you could set this up for the dumbest stuff. Like, you want to stance your car, just kick out the bottom linear actuators, the control arm, your tire is going to be mad cranking, going to be riding on the sidewall. Now, another big concern with this is going to be the size. It is a very large assembly. Due to all these moving parts, you're going to have to leave a lot of tolerance. You're going to have to figure out every possible way the wheel can move with all the maximum settings, and then figure out if it'll clear. The biggest pro I can see, though, because of all this flexibility and movement, is custom tunes. You could, instead of having to get a laser rack and figure out your alignment manually, well, tell the computer, I want X degrees on this component, and I want X amount of pressure and spring rate. Another pro is all the backup systems. So you have a traditional coil over here, because if any of this were to fail, the linear actuators get stuck to hydraulic pressure inside gets stuck, you have a fallback. Now, this is going to be very soft, barely enough to hold the vehicle up, but it is going to save the vehicle in case of a sudden failure on one of the pump systems or the slave units or whatever it be. Yeah, that's about it for this suspension, though. Highly adaptive, very expensive.